boys and girls, so are going to do a little bit more practice on solving one-step equations using inverse operator. Does anyone remember what that word inverse means? Well, if you said opposite, then you are correct. Now let's just do a little review of what is an equation. So if you remember, an equation is a math sentence with, remember, the equal part of the word is in that equation word. So that is a math sentence with an equal. Now, it can be solved without anyone telling you what that variable is. So that is why we are practicing solving these one-step equations with the variable. Now, remember when I started off asking you the question of what does that inverse word mean? Does anyone know? Anyone? Anyone? Well, if you said it's the opposite, yay, you are correct. So I'm going to be using the inverse operation to solve the one-step equations. Now remember, let's just do a quick review of what are the math opposites. We have addition and subtraction are math opposites, and what is the other pair of math opposites? If you said multiplication and division, then you are correct. And that's going to be focused in our final weeks in solving these one-step equations with multiplication and division. Now remember, equations must stay balanced. Last week, I introduced to you, just showing you a graphic concept of how the equation needs to be balanced, such as this balance scale. So an equation must stay balanced. So that means that any changes that you make to one side of the equation, you must also do to the opposite side of the equation. So it has to be balanced. So what if I take one triangle off of the left side of this balance scale? What's going to happen? The balance scale. As you see now, sides have three triangles on it. If we remove one triangle, then the scales, are they still balanced? Would the scales still remain balanced? Take a look at that. No, they are not. So we have to have balance. So what can I do to balance the scale? So what I did to one side, I would need to do to the other side. What to do to balance the scale, ladies and gentlemen? If you said remove a triangle, then you are correct. So let's take a look at the following equation. We have x plus 2 equals 3. Now, if you recall from our practice last week and early on in the few weeks, we have to solve for x. And to solve for x, we want to get everything away from it. If you remember, we used that word isolate. We want to isolate the variable, get everything away from that variable x. So what we do to one side, we must do to the other side. So if we took 2 away from this side, then we have to take 2 away from the opposite side. So what do we have left? We're left with one triangle. So therefore, the value of x is going to be 1. X equals. Now, let's try this the algebra way without using the pictures. So in our first example, we have x minus 3 equals 5. Remember, addition and subtraction, we've been practicing pretty much since started solving one-step equations. So we should know what we need to do to isolate this variable. Can anyone tell me? What do we need to do to isolate the variable? If you said that you need to add 3 to both sides, then you are correct. Because adding 3 to this side of the equation is going to cancel it out. And adding 3 to the other side of the equation is going to give us the value of x. So therefore, x is going to equal 8. Now, we can also check our answer by simply plugging in the value that we found for the value of that variable. So if we plug in 8 for x, is the equation true? Is 8 minus 3 equal 5? Hopefully, you said yes. 8 minus 3 is 5, so therefore we know that we were right. All right, let's do a second example. So now we have x plus negative 2 equals 7. We don't want to let the negative numbers throw us off. So we have a negative 2. So therefore, we're going to add to this side and add 2 to this side to isolate the variable, and cancel out that 2 on the one side of the equation. So now x equals 9. And if we plug in that 9, x plus -2, which is the same as saying 9 minus 2 equals 7. So we know that we were right. So now we're going to move into some examples using the operations of multiplication and division. So here we have 2x equals 14. Now if we remember, anytime we have that x to the variable, what operation are we doing? If you said multiplication, then you are correct. So we're doing multiplication here. 2x equals 14. So remember, the very first thing we want to do is to isolate the variable. How do we isolate? We have to do the inverse operation. So we have the 2x. So we're going to divide by 2 on both sides. Dividing by 2 is going to cancel out our coefficient. And now we have x equals 14 divided by 2. So now we just need to solve for x, and x equals 7. And we can also check our answer by simply plugging in what we found for x into the equation. And remember, when we have two numbers together, we can either use the multiplication sign, or because we're doing algebra, we can use parentheses. So the same as saying 2 times 7 equals 14. So therefore, we know that we were correct. In our second example, now what operation are we doing? We have the bar here, which we know is our fraction bar. What operation is it? That's the very first question we want to ask ourselves. And if you answered with this is the operation of division, then you are correct. So the second thing we want to do after we identify the operation that's being done, we want to isolate the variable. So how do we isolate the variable? We're going to multiply each side by 10. Why are we multiplying? Remember, because multiplication is the inverse operation of division. So we multiply this side by 10, we multiply this side by 10, multiplying side by 10 is going to cancel that 10 out. So therefore, we're left with x on that side. Now we see that the value of x is 20. And to check our answer, we plug in what we found for x into our original equation. So now we have 20 divided by 10 equals 2. Is that true, ladies and gentlemen? It is. Now, here's our last example in which we're going to have a negative number on the inside of our parentheses, but we're not going to let that throw us off. No, we're not. We're simply still going to do the same thing. So the first thing we want to do is to distribute this negative number to the parentheses. Remember, anytime something is on the outside of the parentheses, we want to distribute. Now, when we distribute, this means we're multiplying the negative sign by -4. So therefore, a negative multiplied by negative is going to give us a positive. So now our equation is left with x plus 4 equals -1. So now we just want to isolate the variable. How do we isolate the variable? We have to do the inverse operation. So what's the inverse operation of adding 4? What's that inverse operation? If you said subtracting 4, then you are. So now we have plus 4 minus 4 over on this side, and now we're going to subtract 4 from this side. So now we have canceled out our 4, so we've isolated our variable on one side of the equation, which is always our goal. And now on this side, we're going to add these numbers together. We put a negative plus a negative, that gives us a negative, and we just add as usual and keep that negative sign. So x is going to be -5. And we can plug in that value for x, put -5. Remember, when we're solving the equation as it is, negative minus multiplied by -4 equals -1. So -5 plus 4 equals -1. Is that true? Yes, it is. So we want to also make sure if we have a problem in which the variable is on the other side of the equal sign, it does not matter. It doesn't matter which side the variable is on. In this equation, we have 10 equals x plus 3. So we still want to do the same thing, isolate the variable by doing the inverse operation. The inverse operation here is going to be addition. So first we start off with adding to this side, and now we add 3 to the other side of the equation. So now we are left with x equals 13 or 13 equals x. It doesn't matter which side of the equal side the variable is on. So as long as you practice your strategies in asking those 3 questions, first, what operation is going on? Second, how do I isolate the variable? Then you will be okay. If the variable isn't first, just do the opposite of the number sign. That's totally okay. So in this example, we have -5 plus x equals -9. So the first thing we want to do, once we know what operation is going on, here we're going addition, we want to do the opposite operation to isolate the variable. Use the inverse operation to isolate the variable. So we're going to start off with adding 5 because this was a -5. So we add 5 to this side. Of course, we have to add 5 to the other side of the equation. Our 5 cancels out over here, and we're left with our positive x is going to equal, we have -9 plus 5. So, what is x going to equal? We have two different signs. Remember, when you have two different signs, you're going to subtract and keep the sign of the larger number. So, therefore, x is going to equal -4. And to check our answer, we can plug back in that value of x. We have -5 plus -4. Whenever adding the two numbers with a similar operation and a similar sign, we're going to add those signs together and keep them. So we have -5 plus -4 equals -9. And there you have it, ladies and gentlemen. So you're going to use these steps to assist you with the practice activities that you have for the rest of the week. If you get stuck on anything, please come back to the video, and the videos are always here to help you. Hopefully you had your notebook out and you took some notes. If not, I would suggest going back to replay this video and take some notes, because you never know when the same exact problems that you wrote down in your notebook might just pop up on your practice questions. All right, ladies and gentlemen, let's finish out our final week of learning of online activities on a strong note and carry on our learning to get ready for 7th grade. So I hope that everyone is able to use this video to assist